Okay, so let's look at the first example because I think that'll make it easier for you to follow the numbers. So in this example, Glacier Peak Outfitters has the following direct material standard for its fiber fill in its mountain parka. It's 0.1 kilograms of fiber fill per parka at $5 per kilogram. That's their standard rate card amount of materials. They're supposed to use 0.1 kilograms, and it's supposed to cost $5 a pound. That's what they are expecting. Now let's see what they actually had. Last month, 210 kilograms of fiber fill were purchased and used to make 2,000 parkas. The materials cost a total of $1,029. So now we know what we should have had. That's our standard costs and our standard quantity. And now we have the actuals. So we simply need to plug it into the general model of variances. So let's look at that. As you can see here, there are three columns, 1, 2, and 3. We have actual quantity times actual price, actual quantity times standard price, standard quantity times standard price. So the actual quantity, this was given in the problem, was 210 kilograms. And the actual price, now it didn't give you the price per unit. It gave you the overall amount of spend and how many units it was used for. So you actually have to calculate the $4.90 per unit here, or per kilogram here, on how much you actually spent. But we can see that, we'll see that in another slide. But it's actual quantity times actual price. So the actual quantity used was 210 kilograms, and we spent $4.90 per kilogram on the material for a total of $1,029. So that is our actual quantity times actual price. Actual quantity, again 210 kilograms, times standard price is $5 per kilogram. And so as we look at this, and we can immediately see that, oh, well, we spent $4.90 per kilogram, and we planned on spending $5 per kilogram, so that's going to be a positive, favorable variance for us. We spent less, and if you do the math out, you'll see that we should have spent $1,050. We actually spent $1,029, and then if we subtract 2 minus 1, which is the $1,050 minus the $1,029, you will see a price variance of $21 favorable. So we spent 10 cents less per kilogram on our material, and we should have spent $5 instead of $4.90. And therefore, over the amount of material, the 210 kilograms, we saved $21. That's favorable. So we have a favorable price variance. Looking at quantity, we take the actual quantity times the standard price, which is $1,050 as we know, and then we look at it compared to the standard quantity at the standard price. So the standard quantity is 210 kilograms at $5 per kilogram for $1,000. Now what wasn't given was the standard quantity. So the 2,000 wasn't given. How did we get the 2,000? Well, if we look back up at the program, or at the problem itself says, last month, 210 kilograms of fiber fill were purchased and used to make 2,000 parkas. Well, 2,000 parkas. If we're going to make 2,000 parkas, how much material should we use? What is the standard amount of material for 2,000 parkas? Well, the standard rate card says it's 0.1 per parka. If there's 2,000 parkas times 0.1, we should have used a tenth of 2,000, or 200 kilograms of material. So we had to calculate that a little bit and think about how much material we actually should have used. So there's two calculations. You need to calculate the $4.90 and the 200 kilograms. But other than those two calculations, the problem pretty much is fill in the blanks, follow the model. So if we look back at the 200 kilograms times $5 is $1,000. So our amount of material, the quantity that we used, was we should have used $1,000 worth of material. And what did we use? We used 10 kilograms more than that. We used 10 kilograms more of material. We should have used 200 kilograms. We actually used 210. So we have 10 kilograms more than we should have, and 10 kilograms more than we should have at the rate that we should have paid, $5, is a variance of $50, which is more material than we should have, so it's unfavorable. So that materials, or the quantities of material, we used 10 kilograms too much. That 10 kilograms at $5 standard price, we we're off by $50 because we used more material than we should have. We stuffed a little bit more in the parka. Whatever we did, we lost some of it. Some of it got wet. Some of it got ruined. Whatever. We used more material than we thought we would. Therefore, there's an unfavorable variance. If you take the price variance and the materials variance, or the quantity variance, price and quantity variance, and you combine them, you get the overall variance. So the overall variance here will be $21 favorable, $50 unfavorable. And if you looked at the two, then you get the difference. And the difference, of course, would be that $29 unfavorable would be the overall variance. But you wouldn't know unless you broke it into two pieces that that is the variance difference. So in this case, pricing was good. The purchasing manager is doing their job. They're getting us lower prices. But the quantity, the production line is using a little too much. Either they're wasting some, or some got ruined, or the quality of the material was less, so they had to put more in, whatever. But you can see the difference between the two. One's pricing, one's material. And if you only did the variance between what you thought it would be and what it was, you wouldn't be able to break out exactly what's going on. So let's do some more problems like this. I think it'll be obvious to you that this is a very important system to finding out exactly where you're off in your budget.